on you. You put in the time to memorize it. Yes? Okay. The understanding and the application is for me to help you with. But just the memorization, you have to get down those conditions. So that's why we're making these flippy notes so that you can see. Okay, so we're going to see how do I find if it converges using the nth partial sum, the geometric series, and the nth term test. So those are the three we're going to focus on today. There's that too. Okay, so we have this infinite summation that we talked about that basically this in here is the series part, yes? It's telling us like the pattern. And then this tells us to start at the first and then go by integer values until the end, which would go on forever. Okay, so in this case, and this is what we are trying to decide. Does this equal a number? Or does this equal infinity? Or I guess if it's all negative, like plus or minus infinity. So that's what we're trying to find out. Yes. So if this equals a number, we're going to say that the series does what? Converges. And if it doesn't, if it equals infinity or negative infinity, we're going to say that the series diverges. And that's the whole goal of all of these tests, is determine which one it does. Okay? Now, some of the tests, we can find what it actually converges to. We can find their sum. Okay? Some of the tests, we can't find the number, but we know it does equal a number. Kind of weird, right? Okay. So, and some of them, it gets even more fun. Some of them can equal different numbers depending on how you manipulate them. So I can actually prove that 2 equals 1 in this unit. I know! Okay, anyway, but this is the goal. Okay? Okay, so a partial sum, and that's what we've started on in our free aid. A partial sum just means we stop at some point. We don't keep adding forever. So we've stopped at some point. So the nth partial sum means we stop at whatever nth term that is. So that we stop. And sometimes once we stop, we can see a pattern of what the rest converge to. Okay? And so we can actually find the whole thing. If it doesn't stop and it goes on forever, then we're just going to use S. And if it makes you more comfortable, you can put S sub infinity so that you know, hey, it's forever. But forever is just S. Okay? Good with the conceptual part of the notations. Okay. So let's look at this. If I just wanted to see, this series is written out in an expanded form. Yes. Yes! Okay. So he said this is 1/9. Because he's seeing that this adds up to 0.1, 1, 1, 1, 1, and it keeps going, and we talked that we need to know 0.111 repeating, 0.222 repeating, 0.333 repeating. That's just number sense. That guy is equal to 1/9.
The next slide, we need to.
Okay. So this guy right here, we could try to write it in the summation form, but I know that this guy is going to equal 1/9. So this series converges. And in fact, we found what it converged to. Yes? Okay, let's look at the next one. Remember my joke? You guys remember? If you don't know, you could say, okay, the first one is 1, right? The partial sum of 1. The second partial sum here would be
1.5.
1.5. The third partial sum would be 1.75. The fourth partial sum would be
1.875.
good job. Awesome. Okay, the fifth partial sum, you got that?
Nope.
Yeah, 1.9375. Okay. Can you start to see what this is going to approach?
2.
2. That was my joke about going in and getting a root beer. Yeah.
Oh, okay, I got it.
Okay.
I remember.
Do you need it one more time, or you good? Oh, gosh. Okay, so again, I could write, and we can work on this in a little bit, but I could write this guy into a sum, like with the summation formula, and we would say, yes, it converges. And in fact, I found that it converged to 2. We will practice. Do you want to do it, actually? Okay, so let's write this. What am I doing with each term? I'm multiplying by 1. I'm going to do a fraction. 1/2. Okay. So when I'm multiplying through, this is a geometric. We did a little bit of that. So we have our first term times what we are multiplying by to the n, where we start at 0 and go to infinity. Yes? Okay. And we're going to see this in a little bit. We're going to see what to do with this, okay? And we're going to see exactly how that equals 2 in just a little bit. Yes, this guy equals 2, absolutely. And I'm going to show you how to prove that with geometry, okay? But right now we're just kind of seeing. And actually, we're going to go right into it. Almost. We're going to do the end partial. Okay, so let's look at this. A lot of times, when I first start with these infinite summations going on, so I have these series, I just want to see what are the first few terms. And when you're stuck and you're not quite sure, it's a good thing just to do that anyway. So let's just write out a few terms. Okay? All right. Start with 1, because that's where this started. So that would be 1. I'm just going to write it out, okay? Minus 1/2. There's my first term, and we can't simplify it, but let's keep going. Karen, what's my next term when I plug in 2? 1/2. Good. Autumn, what's my next term when I plug in 3? Okay, and that keeps going, right? Can you see something that is happening? Karen, yeah, what do you see? Okay, so something's going to 0. Taya, what do you see? Just try. Perfect, yeah. She says negative 1/2 and 1/2 cancel, right? What's going to end up happening as you keep going?
Keep canceling.
We're going to keep going out, right? So this is actually 1 for your answer. Well,
Wow, shock.
whoa. Okay. So that is what? This right here, when they start to cancel, is called telescoping. Telescoping. So, and that's what we have right here. Telescoping series are when, like, as you keep going, some of the terms cancel. Okay? Now, this is actually helping us with this nth partial sum. Okay? So, as I keep going forever and ever and ever, my nth, like, my like the nth partial sum as n goes to infinity, is 1. Okay?
Or just go cancel.
Let's look at this next one. Okay, write out the first few terms. So at 1, I am at
4.
4. At 2, I'm at 'What about this guy?
Plus.
Okay, so you're seeing that you're going kind of to this positive infinity part, and you're also going to kind of this negative infinity part, right? But are the terms canceling? Are you seeing anything like that? Okay, you are not. So, and it's growing bigger and bigger and bigger. Yeah, it's kind of like boom, 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 boom. Like you're adding more and more and subtracting more and more, right? So what can you say with this guy? Huh? It diverges. Okay? And again, this is like by looking just at the partial sums of what's happening. Okay? Yeah. Just as long as we know it diverges.
So we don't need to figure out how to
Right. Okay? Okay, so that's just using the nth partial sums. It's really, the nth partial sum as n goes to infinity, you're just writing out the terms and seeing what happens. Okay, so fill in your essential question for that for me. For that nth partial sum. So right here, fill that guy in. Use it, just write some layman terms here, so that you know what you're doing. Okay, so write down the first few terms. See if it's telescoping, right? See if the terms cancel and you're just left with a few of them for a sum. Or see if they just keep growing, you know, and not converging to anything, basically. So look for a pattern of what's going on as you go to infinity. Okay, so now we are on geometric. Favorite one. No, really easy. Okay. So a geometric series, you can see it starting at 1, but we like it to start at 0. And a lot of times, if we see it at 1, we are going to change this. Okay? A lot of times we're going to change it to 0 when we want to find the sum. N equals 0. Now, if we're just looking for convergence or divergence, either one is fine. either is fine, or here, n can equal any number if you just want to converge or diverge. But if you want to find the sum, n has to start at 0. Okay? If I just want to say, yes, the series converges, doesn't matter where you start, and you're going to see this, okay? But if you want to find the sum of what it converges to, we needed to start at 0 in order to apply our formula that I'm going to show you. Okay, so when it does start at 0, then I get what the sum is by this little formula. A is 1 minus r. Not only when it just starts at 0, but the r value here has to be, the absolute value of r has to be less than 1, but greater than 0. This is the condition. Remember when I say you're going to have conditions for convergence or divergence? For geometric, this is the condition for convergence. Okay? This is what it converges to, if it's a convergent series. So if r is not here, then it's basically the absolute value is greater than 1, and it diverges. So can I use the summation formula if it diverges? No. Okay. This is kind of fun. I have some of these little snippets for those of you who want to look on your own into some cool things, okay? And there's a few of them in these notes that are extras. So let's look at this first one. Just to find if it converges. Okay, so let's just say converge or diverge. Do I care where n starts?
No.
No. I just need to find what the r value is. What is our r value here? 4/3. What's the a value, FYI? 1. Okay, we just don't see it. Okay, so r is 4/3. So this means that it does what? Diverges. And when we do this, we're going to have to say what test we're using. It diverges by the geometric series test. So can we even find the sum? No, we don't even have to worry about it if it diverges. Can't find the sum if it's a divergent series. It's going to be infinity or negative infinity. In this case, it's getting bigger and bigger and bigger, so it's going to be infinity. Okay, let's look at the next one. If I just want to know when it converges, or if it converges or diverges, I look at my r. R is what? 2/3. So that absolute value of r is greater than 0 but less than 1 from that condition. So this guy, we're going to put converges by the geometric series. Boom. Now, what if I wanted to find the sum? Say it again. You plug it into the formula, a is 1 minus r, but that only works when what? N is 0. So first, I have to go get it to 0 here, because it was 1. So if I want to find the sum, I have to go change it. Just to know if it converges, do I have to change it? No. So change it. You guys have practiced this in your pre-series notes. Go change it. Thank you. Okay, did you get it to that? So this right here is my A, and this right here is my R. Just a coincidence that they're the same number. So now we can say that this equals, because we get to find the sum for geometric, A over 1 minus R. Simplify.
Interesting.
Well, that's a good thing. I'm actually going to show you something really interesting. It's not AP, but it's so cool I have to show you. Application of geometry. Okay? This is the AP stuff here. Hey, really, really quick, remember how you wanted to see what that one was? You're like, how do we know? Could you do that really quick now? Is this geometric? Okay, so it was A over 1 minus R, which is 1 over 1 half, which is, oh! Okay? Okay. So, remember how, like, when you learned about rational versus irrational?
That's clear.
Rational means that there's a pattern in the decimal or it terminates. It means you can turn it into a fraction. So this right here, see the pattern? This is rational, which means I could turn it into a fraction. I'm going to show you how you can take any rational, like decimal, this repeating decimal, and find the fraction without just having to guess. By the geometric series. It is. It's really, really cool, actually. Okay? You can show this trick to your parents. But, okay. So let's think of it like this. So we're going to think of it like that. Okay. So this guy is 15 over 100. This is 15 over 1, 2, 3, 4. 10,000. Okay. This is 15 over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Do you see what you are multiplying by every time?
100. I mean, divide by 100.
1 over 100. How about that? Same thing. So do you see that you are multiplying by 1 over 100 every time? So is this geometric? Yes. So we're going to rewrite it. Bless you. Into the summation formula. What's our A value? The A value is the very first one. Oh, 0.15, yeah. Sorry, I'm going to use fractions. Yes. What are we multiplying by? What's our R? over 100 to the n. Does it converge? Does it converge? Okay, so I know it's convergent by the geometric. So I can apply my formula. It converges to A over 1 minus R. Let me just get to simplify a little bit. Simplify. Yes? I can simplify that even. 3 goes into both of those.
So how were they?
You believe me? You believe me? Check it. Put it in your calculator. Right, Papa? Make it go back away. Oh, it's not there. I'd have to type it in, but yeah, look in your calculator.
That's not true. This decimal.
So you could do it, okay? Yes, you're gonna get it. Okay. You're getting the trick. Okay, so you can find the fraction for any rational number. That's pretty cool. Come on. Thank you. Thank you. No! Okay. So we're gonna go here. If a series converges, then the limit of that sequence equals 0, is what this is saying. So if the series converges, right, then the limit is 0 as you go to infinity. Okay, that's great. And that can help us sometimes just to know. But this is your nth term test. Okay, the nth term test only shows divergence. And it says, if you take the limit of that sequence from inside there, and you do not get 0, then this guy diverges. So when you don't get 0, it diverges. What happens if you get 0? No. So if this guy equals 0, guess what? Yeah, we know nothing. Indeterminate. Don't know. Okay? We don't know anything. This is useless. Okay? Okay. Don't worry about explaining for time right now. Just tell me true, false on 1, 2, 3, 4. This would be really good for multiple choice, like, you know, which is true.
True, false. True, false, true, false. False.
Okay, well, which ones can you definitely tell me that we just learned are true?
First one.
2 we just saw from the previous, but this is true.
4.
And 4 we just saw, that's our nth term test. That's definitely true. This is our test. Okay, that's definitely true. What about the other 2?
False, true, false.
They're both false. Okay? If the limit get the limit to still be 0. Okay? So they only go one direction. They don't go both ways on that infinite here. It's just one thing. Okay, so let's look. Oh, we got one more page. At some examples. We're going to be using the nth term test here. So let's look at this guy. That right there is our a sub n. Yes?
Yeah.
Okay. So I'm going to look at the limit as n goes to infinity of 2 to the n. And what do we get out?
Infinity.
Infinity. And if we just wanted to start writing out some of the terms, that'd be what? 2 plus 4 plus 8 plus... Do we basically see that? Yes. And now we can actually state that this series does what? Diverges, and you have to tell me what test, by the nth term test. Okay? This guy does not equal 0. That's all we had to show. Let's go to the next one.
Oh.
That's my a sub n part. So let's look at the limit as n goes to infinity of n factorial over 2n factorial plus 1. Kind of growing at the same rate, right?
But this times 2.
So we're going to look at the coefficients in front when they're the same rate. It's like bigger on top, bigger on bottom, or the same. So what do I get out?
No, that's
1 half.
That's the convergence, I'm right.
Yeah. Okay, so just like the horizontal asymptote things that we always did. So guess what? This guy is not 0, so what does this series do? What it diverges by nth term test.
Can you explain what he's
Yes, I can. Okay, so if I had n over 2n plus 1, and I was taking this limit as n goes to infinity, what would you tell me the answer is? Huh? So remember when we looked at the powers, bigger on top, bigger on bottom, are the same? They're the same, so we take the coefficients to get the answer. If this guy, though, was squared, it's bigger on top, so we would get out infinity. If that was just 1 and this guy was squared, it's bigger on bottom, which goes to 0. So it's those 3 rules that we were doing before with the horizontal asymptote. Is that okay? Okay. Okay. What happens here? What do I get out? I get out 0. Yes? Converges. Can I say that? If the limit is 0, do I get to say convergent?
Nope.
Great question.
What?
I was no.
How? Okay, we don't know anything. If it equals 0, it could still converge, it could still diverge. We don't know.
So it's spicy.
Okay,
They don't
so if term test
Yeah.
doesn't tell us anything, oops, if term
Yes.
test doesn't tell us, ugh, we're going to have to try something else. And you're going to learn that tomorrow. To be continued. Okay. So see if you can apply what we've learned here.
So, come with it.
This one's fun. This is from an AP test.
Oh, that's cool. I see it.
So I'm seeing that the pattern, right, goes 48 plus, we don't know, plus 12. What would that one have been? Do you guys all see that okay?
Yes.
No? It tells us it's geometric. So I know that I have to be multiplying by something, right? Okay, so what are we multiplying by? Let's half. So this guy, let's start at 0. What's our first term? 48. Our R is 1/2. So can you finish it? So do your A over 1 minus R.
There you go. I was like, I think.
No, because we started at 0. So we basically made that our 0 term. I know that they had like A sub 1 as that. Yeah, if you did that, you could try to adapt it. But we can always just look at the pattern and say, there's my first term. That's what I'll multiply by. So A, that's what she was just saying. 1 minus R. Okay? Yeah, but remember, like, if we started at 1, we can adapt it, right? It's okay. Yes. Okay? Like, we could adapt this to start at 1. But in order to find the sum, we needed to start at 0. But the sum will be the same thing. Okay. Fill in your other 2 essential questions. And then we're going to look at our flippies together. Oops. So go fill in our other 3 essential questions.